This time we will look at sequences, but in summation notation. Okay, so we're going to write an expression for the apparent nth term or a sub n of each sequence. So the easiest thing I would do to start off with is to label the first term n equals 1, the second term n equals 2, the third n equals 3, and etc. And the reason why is sometimes you can start to kind of see number patterns. So if we look at our situation here, 1, 2, 3, 4, our term number is in the denominator. And if we look at our numerator, each subsequent numerator is 1 larger. So we said each term has a numerator 1 larger than the denominator. So therefore we can write our sequence as a sub n equals n plus 1 all over n. Okay, so we'll do something similar in letter B. So we're going to follow a similar process. B is a little bit more challenging, but notice we have our first term is 2, our second term is -5, our third term is 3 or 10, and our fourth term is -17. And we are just going to kind of figure out what the pattern is. We notice that every other term is negative. And, oh, that was weird. And each term alternates and even terms are negative. So once we've established that, let's ignore those sign changes and figure out the general pattern. So it looks like we are squaring the term and then adding 1, right? 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. And then to combat that sign change like we talked about previously, -1 to the nth power. Remember, odd term numbers are going to give you a negative, but in this case we want even term numbers to be negative. And now I would like you to try the example. You try. And hopefully you found a sub n equals 3n minus 2. Now these problems can be quite challenging, a lot of guess and check until we learn our types of sequences will be critical. Now we're ready to talk about summation notation. So notice the sum of the first n terms of a sequence is represented by this following form, where the I is called the index of the summation, n is the upper limit of the summation, and 1 is the lower limit of the summation. Okay, so essentially what you really need to remember is the bottom is where you're going to start the sum. The top is the term number you will stop, and a sub n is the actual sequence. Now this sigma just means the sum of the I terms. Okay, so let's look at a couple examples. So now we'll just find A. So notice we're going to start with 0 and we'll substitute the I equals in for the I. So 2 times 0 plus, now notice at the top that's where we stop. So we want to go until we get to the fourth term, okay? So 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4. And that it matches our stopping point, so then we stop. Now we just simplify and add together. 0 plus 2 plus 4 plus 6 plus 8, which gives us a total of 20. The end. Let's look at B. This time we're going to start at 2. 1 minus 2 squared. And remember, you're going to replace the k. And this time we'll stop when we get to 6. So our next term, 1 minus 3 squared plus 1 minus 4 squared plus 1 minus 5 squared plus 1 minus 6 squared. Okay, and we've gotten to that 6. We can stop and simplify. So looks like, well, 1 minus 4 plus 1 minus 9 plus 1 minus 16 plus 1 minus 25 plus 1 minus, oh, I put the squared in the wrong space. Whoopsies. Scribble those out. 36. And then we clean it up further. So negative 3 plus negative 8 whoop, plus negative 15 plus negative 24 plus negative 35, which when we add all those terms together should give us negative 85. That's all. Okay, and in letter C, notice this time we are going to start at 1, but there's no I with our sequence. So we're just going to write the 3 for 5 terms. So this, remember, represents the first term. Oh, plus 3. This represents the second term. Represents the third. Represents the fourth. And the fifth. And we know we're stopping at the 5 because it's at the top of our notation. So we just are gonna, add 5 3s together. 15. I would like you to take a minute or two and try these 2 example U-trays. So hopefully you found in B to be 20 and in A you found to be 47 operations. Okay, so this time we're going to do summation notation. Okay, so we're always going to start with a big sigma. Remember the bottom is where you're going to start. So if we look at our first term, we notice it's a 1, and then it goes 2, then 3, dot, 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 all the way to 7. So we know we're going to stop at 7, and we're going to start at 1. And what are we doing to each term? It looks like we are cubing it, so we'll put n to the 3rd, and that's it. Let's look at B. So if we look at B, notice we start at 1 and we stop with a 3 to the n minus 1 power. So because there is no n term, this is an infinite sequence. We are still starting at 1, and this actually is our summation. And that's it. And now you have 2 to try. Yay! Hopefully you found for letter A, you start at 1, stop at 9, and your sequence is n squared. And for letter B, you start at 1, stop at infinity, and your sequence is 1 over 2 to the n minus 1 power. Yay, it's time to do practice. The end.